All right, we are going to talk in this lesson about solving two-step equations. All right, this is a Math 7 skill that you're expected to know. This particular lesson will focus on whole numbers with two-step equations. A future one will also bring into account rational numbers with two-step equations. We're going to lay the foundation with this and then build on it later. So you should have your notes opened up in front of you and be paying good attention. Again, as the video is going along, at any point, if you need to pause, please do so. Okay, I'm going to keep talking through these problems and these key concepts. But again, at any point, if you need to pause it so you can catch up, or back it up if you need to see something again or hear something again. All right, let's get going. So the big ideas in this unit that will come up in this particular lesson are that equations are two math statements that are equivalent. That equal sign is very important, and we're going to always try to keep that balanced. So they are equivalent. What's on the left is equivalent to what's on the right of the equal sign. And we also know the equations have one solution, all right? That's going to surface over and over again in this lesson. One of the essential questions that we just keep our building on right here is what process can we use to solve equations? I will just remind you that there are simple one-step equations that many times we think we can do mentally. And there's nothing wrong with mental math. There's nothing wrong with that. My reminder, though, is that sometimes when we do things mentally here, rather than learn a good approach to that problem, then later on, mental math isn't so easy anymore. And then it's not so easy when we get further beyond that as well. So like I said, mental math is good. It's great to think about things mentally. But the challenge here for all of us is to make sure that we are understanding the process to solve equations, whether it's one step, two step, three step, whatever. So learn the steps so that later you know the steps, all right? I am going to continually show you the work for these problems. On your paper, you should write those down. You should show your steps, all right? Because it will just make your life easier as you go into future advanced classes, all right? So that is the plan. All right, that being said, let's begin solving two-step equations. Well, there is a series of steps we will follow, all right, to help us solve two-step equations. Doesn't matter if we're talking rational numbers, whole numbers, integers. This is the same series of steps that we're going to follow. The first step is that we want to undo addition or subtraction with its inverse operation. So we want to first get rid of the addition or subtraction by doing the opposite. After we've done that, we then want to get rid of multiplication or division with its opposite operation. Okay, remember, inverse means opposite. After that, we want to isolate the variable, and we want to always check our solution. So the steps here are the same as they were for one-step equations. We pretty much want to get the variable by itself. We call that isolate the variable, okay? Our goal is to isolate the variable. And then when we get a solution, we want to check it. We want to double check it, make sure that it's right. Because like we said earlier, every equation has just one solution, all right? There's one number that should work. Now, you see here in these pictures down here, some algebra tiles, all right? And they're showing you right here that something over here equals something over here. So if I were to put a problem to this, I see two x's and I see four ones. So if I were to just show that, that would be that right there, 2x plus 4. And that's going to equal, any guesses? That'll equal 3. We're just putting an equation to what we're seeing here. 2x's and 4 is equal to 3. So this is where we came from with that one. Now, if we want to solve this, we just kind of just go to our steps up here. We want to get rid of the addition or the subtraction. We want to get rid of that first. And the way we get rid of adding 4 is that we subtract 4 from both sides. And if we do that, well, this will cancel out on the left. And on the right, we're left with -1. So we have 2x is equal to -1. Where'd that 2x come from, you say? Well, it was right there. This canceled out, but that's still on the left side of the equal sign. We also know we are taking away more than we had, That's where we came up with -1. Now, we want to get the variable by itself, and the next step would be to undo the multiplication or division by doing its opposite. Well, right now the variable is being multiplied by 2, so to undo that, we divide both sides by 2. And over here, the 2's will cancel out, and we have now isolated our variable. X is all by itself, and over here, -1 divided by 2, well, that would just be -1/2. Or -0.5, okay? So that is kind of what we're doing here. We're starting with problems like this for most of the lesson, and we're getting it all the way down to the variable, okay? If I look at the one over here, can you think about what this is right here? How many X's do you see and how many 1's do you see? Because that will lead us into our problem. Well, that's right, 3 X's plus 2 is equal to, well, there's 2, 4, 6, 8. That's equal to 8. So that's what we're working with for this next one. 3x plus 2 equals 8. And again, start with the addition or subtraction. Get rid of that first. And so we want to subtract 2 from both sides. All right. So we subtract 2. This will cancel out. This will become 6. So we're left with this. All right. Now we have that. 3x equals 6. And now I want to get rid of the multiplying by 3. So I do the opposite of that. So I divide both sides by 3. And we are left with x equal to 2. Now, we can think about these visually. We could also think about these numerically just by plugging it in. If I plug in a 2 up here, that would be 2, 4, 6, 7, 8. And we already know this side was 8. So that checks, okay? We could also plug in the 2 right here and see if it works. Well, 3 times 2 is 6, plus 2 is 8. So our solution is good. We could have done the same thing over here. Okay, we could have plugged in -1/2. If this is -1/2 and this is -1/2, they would combine for a -1. And I have 4 here, but if I combine it with a -1, I really have 3. Okay, that's why this solution works. So our solutions check out okay, but keep these steps in mind, all right, as we go through these problems here. Solve each two-step equation below, then prove that your answer is correct. So if I look up here first, we want to first get rid of the addition or the subtraction. So we're gonna, right now we're adding 10 to our variable quantity. So we want to subtract 10 from both sides. We want to get rid of that. And if we do that, that leaves us 3k on the left, and it leaves us 12 on the right. Well, now I want to get rid of the multiplication. Okay, so it's being multiplied by 3. So if we want to isolate the variable, we have to now divide both sides by 3. And that will cancel out the 3's. So I'm left with the k. But over here, I'm left with 4, because 12 divided by 3 is 4. So k has a value of 4. Now, they do want us to check our work here, okay? So if I plug in a 4 back into my problem up there, I'm really solving this. 10 plus 3 times 4. Again, that was 3k. Well, we're trying to prove that k is 4, so this would be 3 times 4. And we want it to equal 22. Well, if I solve this, that would be 10 plus 12, which I know is equal to 22. So yes, my solution checks out just fine. If it didn't, then something was wrong and I want to go back and figure out my error. And number 2, again, ask yourself what's happening with the variable. Well, we want to get rid of the subtraction or addition first. Well, here it's subtraction. So to do the opposite, we would add 5 to both sides. All right, and if I do that, on the right side, that cancels out. We're left with 4 times the variable. And on the left side, we have 24. All right, so I'm just going to rewrite that new problem as that. Now, again, we want to isolate the variable. So to do that, we have to do the opposite of multiplying by 4. So we divide both sides by 4. And that will leave us with the variable on the right. And on the left, we'll have a 6. All right. Now, the reason these are called two-step equations is because we're getting from here to here really in 2 steps. One step was to get rid of the subtraction. The other step was to get rid of the multiplication. And in so doing, we should arrive at our solution in 2 steps. Notice these are a little bit more work than one-step equations, but not that much more work. So let's plug this in just to make sure. I'm going to rewrite the problem, but with our answer plugged in now. So 19 equals 4 times 6 minus 5. Okay, so do the multiplication. We get 24 minus 5, which that is 19. So it checks out good. This third one right here, you want to think of this as really dividing by 2, or divided by 2 minus 8 equals 16. So again, first things first, get rid of that subtraction, all right? So add 8 to both sides. After we do that, that leaves us with this. We still have r divided by 2 over there. I rewrote it this way. You could write it as a fraction if you want, but that will equal 24. And so now to isolate the variable, we've got to do the opposite of dividing by 2. So we multiply both sides by 2. And this cancels. And over here, that's a 48. So we're essentially saying that r has a value of 48. Now, we want to double check. So again, plug in a 48 for r and just rewrite the problem. 48 divided by 2 minus 8. It should equal 16. So if I do 40 divided by 2, I get 24. And then if I do the minus 8 part, I get 16. So it checks out okay. Now on the back of that page here, we want to solve these. I know it says to roll a pair of dice and find the sum of the two numbers showing and then solve that problem, but really we're just going to work our way through these, okay, because we'd solve them all in the end anyways. All right, so if I look at number 2 and 3, let's start with 2. 4x minus 8 equals 32. I'm going to work them over here. So to get rid of the subtracting 8, we would add 8 to both sides. And then after we do that, we end up with 4x equals 40. Well, now we want to get rid of multiplying by 4. So we divide both sides by 4, and we're left with x with a value of 10. Now let's just double check it. So I'm going to rewrite that with a 10 plugged in. 4 times 10 minus 8. I know that's 40 minus 8. And I know that that equals 32, so we're all right. Our solution was good. That is correct. Our solution is that x is 10. That's the only value that makes that one true, because these are equations, and like we said earlier, equations only have one value. Number 3, 6x plus 9 equals 27. So if we're doing that one, first things first, get rid of the adding 9. So let's subtract 9 from both sides. That will leave us with 6x equal to 18. Now I can get the variable by itself in one more step by dividing by 6. Again, both sides, always look for that balance, keep them balanced. And our x will have a value of 3. So let's check it. 6 times 3 plus 9, well, that would be 18 plus 9. And that is 27, all right? I know you're seriously wondering, do we have to show all these steps here? The answer is yes, you want to, you need to, you should, all right? Just get in the practice and the habit of that. 4 and 5, let's go ahead and check these. X divided by 4 plus 8, it should be 41. So if we write the problem out like that, we want to first get rid of adding 8. So we will subtract 8 from both sides. And that leaves us with x divided by 4 on the left and the 33 on the right. Well, now I want to get rid of dividing by 4. So I will multiply both sides by 4. And that will get the x all by itself. And that will give me 132 on the right side. So that should be our value of x. Now let's check it. 4, that's not right. This would be 132 divided by 4, which is 33, plus 8 is 41. So this right here is not going to be right, so ignore this, but you should show it the right way, okay? So go ahead and show that the right way. In number 5, you have 9x minus 10, and it's equal to 62. So what's the first thing we want to do? Just solve this. We want to get rid of subtracting 10. So we cancel it out by adding 10 to both sides. This goes away. We're left with 9x. And over here, we're left with 72. So now we want to get rid of the 9, so it's being multiplied with the variable. So we want to divide it. We divide both sides by 9. We end up with x having a value of 8. Let's see if I did this part right. Let's check it. 9 times 8. Hey, good one, Mr. H. Minus 10. It should equal 62. So that's 72 minus 10. And yeah, that is 62. All right. All right, so that's 4 and 5. Now, I want you to try the rest of these on your own, 6 through 12. So go ahead and pause it, show your work, make sure your answer is right, and then come back when you are done and ready to check. All right, check your work. Go ahead and pause it if you need to. I did not show all of the work for these ones, but if you are stuck or confused, double check your work first, and then let me know later if you're still not seeing it, and we can talk about it. But I am moving on, so pause if needed. Now, one thing I want to point out, I don't know if you caught this or not, but we are very used to the order of operations. Okay, we know that certain things have greater value in problems, and when we try to simplify them, we do those first. We start with the parentheses, and then exponents, and then multiply, divide, and then add, subtract. So when we're simplifying expressions, this is kind of our order of operations. Did you catch, though, that when we are solving them, we kind of go the reverse order? That's why we were kind of getting rid of these first in each of those problems. We wanted to get rid of the adding or subtracting first, and then we wanted to get rid of the multiplying or dividing second. Okay, these are two-step equations, so that's kind of why we came at it the other way, because we're essentially undoing a problem. When we were dealing with the order of operations, we were always trying to solve it to get to the answer. But now when we have the answer and we were looking for the variable, we're really kind of going the other way, all right? That's why these two things kind of go hand in hand. So we were really undoing the order of operations in all of the problems we were doing. We were starting with the things that were least important and undoing those, and then working our way up the ladder, okay? So I don't know if you caught that or not, but that's just a little bit of math background knowledge for why we were doing what we were doing. All right, so summarize today's lesson. Here we go. It is just this right here. A two-step equation is an algebraic equation that we can solve in 2 steps. Once you've solved it, we have found the value of the variable that makes the equation true. So that's the summary of today's lesson. You might want to pause it and write that down. But that brings this lesson to a close, all right? This lesson is over. It's finally over. But the only thing I will say before I turn this off is wait till we throw in rational numbers. Then it gets real, all right? That's it. Have a good day.